In this video, we'll be looking at proof by mathematical deduction. This involves writing some algebra and proving one statement and leading one side of the equation being equal to another, or proving identity, where you have a left side and a right side. So let's look at these first few examples. Now, in general, the pattern is that you, in some cases, you've been given some geometry, then you have to prove them, and you start with some known facts and theorems, such as Pythagoras. You can always use that, and then clearly show the logical steps, and your statement of the proof is complete. This is called proof by deduction. So let's look at the very first example. The question statement is saying prove that the product of two odd numbers is odd. Okay, I should have a double quotation there as well. So representation of odd numbers is in general 2k plus something, plus 1, sorry. It is k, it can be any letter of your choice. K is a natural number, alright. Natural number means it's counting. We're counting with 1, 2, 3, 4, and so on. So K, you can use M, N, any letter you like, doesn't matter. This, what's important is that we're saying it's a multiple of 2 and then we're adding 1 to make it odd. Alright, so it's needless to say, but if you had to represent even numbers, then what you use is just 2k or 2m, 2 something. 2 times any integer will make it even because it's a multiple of 2 now. Okay, so these are the things you need to remember. These two facts, you will use them again and again if you have to represent odd numbers and even numbers. So if we want to say product of two odd numbers, we write one of them, odd number 1 as 2k plus 1, and let's say odd number 2 is going to be 2m plus 1. Alright, so multiply them out. What is 2m plus 1 times 2k plus 1? So multiply out the brackets, you end up with 4km, and you have plus 2k plus 2m and plus 1 at the end. So if you check these terms here, all these three terms have a common factor of 2. I don't care about I know they have common factor m and k, but actually I want to factorize a 2 out of them because, let me just do that. I'll write a k plus m here and a plus 1. So what's inside the bracket is just integers, alright? In adding integers will give us some other integer. Will add up to integer, means a whole number. So we having the same format that we started for an odd number, remember? This was format of an odd number. 2 times some integer plus 1, and we have this plus 1 at the end. So format for odd value, right? And this is in the same format, isn't it? So that's it. We proved it. We proved the statement. So you write a little conclusion. You write therefore this shows that it's a odd format. Therefore it's a odd integer. All right. Oh, it's an odd number. Okay. So with these proofs, it's good to write a little sentence at the end to make sure the examiner is understood what you mean. So and then same product of two odd values. Alright, and then you write equal so that the examiner follows this line here. These equal signs, when they come under each other, they just make it nice and neat, and the format makes sense. Alright, so let's look at the next example. This next example, we've been asked to prove that one side of this identity is next to the other, is equivalent to the other. This triple equal sign, triple dashes means it's equivalent to. It's not an equation, so don't treat it like equation. You can't add or subtract, or you cannot divide from left to right. So you start with the left hand side. You indicate LHS means left hand side. All right, and then you try to expand the brackets. Just do two brackets at a time, like I did in the very first lesson, chapter one, and then you multiply this bracket by the second bracket, and you get terms that can simplify. I would have used the table method here, but such is life. So this simplified version is the same as right hand side. This RHS means right hand side of this, be referring to right hand side of the original question. Okay, so if you don't remember, I would have used a box method here where I write the question on the top here. This line here, I would have performed this like so. This multiplication, just so you don't make a error somewhere. I would have wrote them like so, that minus 35 here. So here's 3x cubed is plus 6x squared is plus 2x squared is plus 4x is minus plus 35 times 3, that's 90, and 15 makes 105x. So, and minus 70 here. So when you add these two terms here, this 100 and minus 105 plus 4 gives us this minus 101x. This 6x squared plus 2x squared gives us this 8x squared, and this 3x cubed and minus 70 remain as they are. So you would be less likely to make an error if you wrote the question in this box method and multiplied it like so. So in this next example, we've been asked to prove that if x minus p is a factor of fx, then f of p is 0. Now, you say, if there's f x is a factor, then I can substitute p into the equation, right? So what we're saying is that x minus p will give us a 0. All right, this is when I'm plotting the graph here. I don't know what the polynomial f of x is. Maybe it's a negative quadratic, quartic here. So this f of this x minus p, xp, I know x equals to p, but xp is a factor that would give me a 0. So when I multiply that xp by some other polynomial, which is the division product, imagine we divided f of x by x minus p. So we did this f of x here divided by x minus p, and we found this g of x. That's the answer to this division. That's where this g of x comes from. So when we multiply g of x by 0, we're going to get a 0, right? So we are using the fact that x is a fact, x will be p, and 0 times g of p will be 0. That's why f of p equals to 0 when we substitute it. Alright? So then we're going to look at this next question. We've been told to prove that these coordinates are vertices of a right angle triangle. So there's two ways of doing it. You can either use the Pythagorean theorem, find the distances between coordinates, or you can use the gradient method to prove that two of those gradients are perpendicular or to each other. Now, you wouldn't get a perfect sketch here. Don't try to guess it. But guessing also works. You can do this. You can say gradient of A to B, figure that out, and it would be 1. We're just using those values there. Gradient of A to C, we're going to use it and find this 1/3. So far we don't have any perpendicular gradients. This product of these two is not -1. So we figure out the gradient of B to C and it's a -1. Voila. Because the product of A to B, the gradient of A to B and these two products is a -1. We have a perpendicular, two sides of the triangle are basically perpendicular, therefore it has to be a right angle triangle. Alright, so this next question, or rather this next example is saying we have this quadratic, there are some unknowns for, in that quadratic. K is a constant, no real, it has no real roots, okay? So this means that what it's saying is that is actually cannot be zero, all right? It's just saying that doesn't actually cross the x-axis. It's rather confusing. This equaling zero means that it will never equal to zero for any value of x because the constants here. Sure, we're gonna prove that k is satisfying this inequality. Now, when you have to prove something, there's no point starting with this what you've been given to prove. You just have to use your background knowledge and think what assumptions can I start with so that this will be the result of my proof. There's no point, don't manipulate this, okay? This will be the result. So don't try to manipulate. There's nothing there to do with that inequality anyway. So if you remember, what did we learn in chapters? When did we look at this? I told you this first in chapter 3, remember? We looked at the discriminant. If it has no real roots, okay, means the discriminant has to be negative. So we're going to pick out the value of A, B, and C and put them into this expression here. This is the discriminant. And we check whether it's positive, negative, or what. Actually, we will, no, we're not checking it. We are setting it to be less than zero because we are sure there is no roots. Okay, that we not okay. We've been told there is no roots. We can use that fact here. This is a fact that this is an assumption that you can use. The assumption is that there is no roots. So now, what is A? A is a K. B is a 3K. And C is 2. So I'm going to write here 3K and square it, because that's the value of B here. Yeah. And then 4 times K, and value of C is 2. So I'm going to set that equal to below 0. That's 9K squared minus 8K. Is less than 0. Now factorize that. What you notice is that you can factor in k out of this. You get 9k minus 8, which is exactly what it looks like we got there. If you now plot this inequality for yourself to find the value of k, values or range of values for k, you say if that was equal to 0, one of the roots would be 0 because of that k there. You would think of it as k minus 0 inside the bracket, right? And the other root would be solving 9k minus 8 equals to 0. Take 8 to the other side and divide by 9. You end up with 0 would be on the left and 8 over 9 would be on the right. And we want the y, this is representation for y, right? So like y being less than 0 means that go under the x-axis, and values of k are between 8, 9, and 0. Alright, so we've proved that there, that the k will satisfy this inequality. Alright, so let's look at the next example. I've made a few more examples. Right, so in this last two examples, you've been told to prove that that expression there is a multiple of 8. So because in the book there wasn't many examples with multiples. What it means is that any multiple of 8 will be in the format of, if I manipulate this algebraic expression here to start with, I should end up with something that's got 8 as a factor. Okay, it doesn't matter what goes inside the bracket, as long as I factorize an 8 out in this the third step, or I've tried to put the steps there for you so you know. At some stage we will have to factorize an 8, and that's enough to show that it's a multiple of 8. Do you understand? All right. So let's see what this expansion of the brackets things will slightly get. Uh, well, it will fall into place. So once I expand those two squared brackets, that means multiplying these two brackets, multiplying them out. Make sure you use brackets when you're adding or subtracting. So I'm just simplifying that. Bam. You see the 4n square cancel. This 4n minus a minus makes these two, as the where 8n comes from. And this 1n minus 1, this is really minus 1 because of that. So they cancel. We got 8n. So factor that out and say 8n is 8 times 1n, or 8, you could just write written as a bracket there. So we actually end up with the n inside the bracket. Does So this is just to say at the end that 8 times n is always divisible by 8, and hence is a multiple of 8. Alright, pause the video, have a go at this next question. It's similar to this question here, and then play the video and I'll show you the answer. So after you expand these brackets and perform uh, simplifications, you see 20n, you need to factor it out as a multiple of 4. So you factor 4 out of it. There's no point writing 20n is 2 times 10n or something like that. That's proving, if you said prove that it was even, always even, then you would factor a 2 out. But here you're gonna factor a 4 out, okay? And write a little conclusion at the end. Alright, so the questions in your textbook are like so. You only need to start from one side of the identity and prove left equals to right. Now, these involve using your knowledge of simplifying thirds, rationalizing thirds. Here you have to complete the square for question 5. Question 1, you're proving is even, so use 2p plus 2p or 2 something and substitute that into the expression like I'm doing here, and so on and so forth. So I shouldn't be showing you the answers here. Pause the video and have a go, and then have a go at the play the video. Okay, I'll see you in the next video.